Okay, today we're going to learn about energy efficiency. We're going to see what energy efficiency means, we're going to apply it to a real life example, and we're going to see how to use this equation here. So first of all, what does energy efficiency actually mean? What energy efficiency means is what proportion of the energy supplied in a particular situation is being transferred into a useful form. Now, to try and make sense of this, we're going to have a look at a real life example. So a real simple example here of just a battery powered fan. So here's just a fan here, and when you switch it on, the blades turn around and it blows air to cool you down, okay? So first of all, we need to think about the energy transfers that are going on in here. So the energy that it starts off with energy in the chemical store, because we have energy stored in the batteries. Now the useful energy transfer that we're getting is we're converting energy from the chemical store to the kinetic store. So the kinetic, remember, means movement. However, this is not the only energy transfer that's happening here. We also have an unwanted energy transfer as well, because we are also transferring energy into the thermal store. Now, the reason for that is whenever we have work which is done mechanically, like the spinning of these blades, we have frictional forces. And those frictional forces causes a transfer to the thermal store. So the energy is dissipated to the surroundings. So here we have energy being converted to the thermal store. Now in this particular context, it's not useful to have energy lost to the thermal store. It would be preferential to have all of that energy converted from the chemical store to the kinetic store. But like I said, whenever we've got these moving parts and these frictional forces, we have energy which is wasted to the thermal store. So now we need to have a look at how this particular example relates to this equation here, because efficiency is the useful energy transferred divided by the total energy supplied. So let's see what that means. Now let's imagine that within this battery, we're supplying this fan with 8,000 joules of energy. So that is the total energy which is being supplied to this battery powered fan. Now let's imagine that thermal store, let's imagine 2,000 joules of energy is converted to, is basically transferred to the thermal store. So what we've got to do now is, with this information, we've got to figure out what is the efficiency of this battery powered fan. So the way that we do it is like this. First of all, we need to figure out the useful energy which has been transferred. So if we have a quick look, we can see that we were supplied with 8,000 joules. So that was my initial energy, 2,000 of which has been converted or transferred to the thermal store. So all I need to do to find the useful energy, using the idea of conservation of energy, so no energy is lost, no energy is created or destroyed, it's just converted from one form to another. If that is how much is converted to the thermal store, the rest of it must be useful energy, i.e. converted to the kinetic store. So 6,000 joules is useful. So now I've got that information, all I need to do is put it into this equation. So my efficiency is nice and simply the useful energy transferred. Now I've worked out my useful energy transferred here. This is the amount of energy that gets converted to the kinetic store, which is 6,000. And I need to divide that by the total energy supplied, which is 8,000 joules. Remember, whenever we're dealing with energy, the units are always joules. So the answer to this is, I did this on a calculator previously, but please always use a calculator, is 0.75. Now it's absolutely fine to leave this as a decimal if you want to, or if you would prefer to express it as a percentage, you just need to times it by 100. So either of these answers here are perfectly acceptable answers to show the energy efficiency of the transfers within this electric fan. The quick check to make sure you haven't made a mistake is this number here should never be over 1 if you've left it as a decimal, and this percentage here should never be over 100 if you've expressed it as a percent. So that basically is how energy efficiency works. Thank you.